Hello, everyone, and thank you for joining our call today. Today we'll have a presentation on reputation system and identity. And Maxim, you can just go ahead.
Hi, everybody. I will start with the screen sharing. Oh. Today, sorry, something wrong with my throat. Today will be not a usual call, probably because it wouldn't be so much technical or business oriented. It will be more about contemplations that we have and thoughts that we have, and we were working for a while, for more than a year, around the ideas of identity, naming, reputation, and in particular, because today NFT is very popular. In fact, these are all forms of NFT. So at the very end, we also will touch an NFT topic. And I would like to share the status of the research in this regard, because we are releasing RGB schemas. Basically, it's a template for the smart contracts built on RGB. And we strongly believe that RGB applications are much beyond the idea of doing fungible tokens or even usual NFTs like digital art or virtual items. And the real power of RGB probably can be shown with a complex system like reputation-based systems for construction of complex incentivization and trustless economic schemes without introducing additional tokens, in fact. Because RGB is a smart contracting system primarily. So I'd like to share my thoughts in this regard and hear a feedback. We will be gradually building all these systems, but I'm quite sure there is still a lot of time ahead before we will have something production ready. So, first of all, I would like to start with the design goals. These are actually design goals for all the technology that we are developing. It's basically the values behind what we call LNPBP association, and also values behind RGB. And of course, we do apply them for design of particular smart contracts, including the identity and reputation. And they are especially important in context of identity and reputation because the existing solutions, and there are plenty of solutions for identity and for decentralized naming. And I think the main problem with them that they fail in these values. And basically that's why we need something different. And because RGB is designed according to these values, we believe that it will be possible to build such system utilizing its technology. So what are these values? There are basically 6 of them. The first value is anti-fragility. And probably it is the stuff that is normally called decentralization, but I strongly disagree that decentralization is the thing that is important. What is actually important is that anti-fragility that appears sometimes from decentralization, and it's more important to have an anti-fragile system than a decentralized system. I will explain what I mean. I do believe that decentralization sometimes is a poor design or malfunctioning design even. For instance, I have a very centralized entity which I would not like to decentralize, at least while I'm alive. This is myself. I don't want to decentralize myself as a human person, as a human body. I don't want to decentralize the stuff that I own. It's my ownership, and this ownership shouldn't be taken from me and decentralized to community, because it's more a communistic thing. And frequently, those who are building decentralized technologies, like in the Ethereum community, they really do this shift in values from decentralization to building some type of socialistic or communistic systems. So that's why I think that calling the value decentralization is not the right way of calling it. The real essence of what we need to do is to build anti-fragile system, even if they are intrinsically and naturally centralized, like concept of ownership. And of course, concept of identity is also centralized because I am the owner of the identity. The identity management can be decentralized and made by this decentralization anti-fragile, but not identity itself. The second value is build something that is individualistic. And I was thinking about how to name that probably and properly, capitalistic, anarcho-capitalistic, or somehow else. Well, in fact, it all comes to the individualism, because individualism is basically the only antonym to collectivism and different forms of collectivism, like socialism, communism, fascism, Nazism, whatever, maybe even communism. So individualistic is meaning that the technology targeting not the community, not the society, not the collective, not the common good. It targets only the individual user, and it should be beneficial to the individual user, not to the society or common good. That's the core value. The third value is the system must be confidential. And it actually is a consequence of being individualistic, because you wouldn't be able to protect your rights, your ownership, your centralized ownership, your individualism, being not confidential, being open to the whole world. The fourth thing is censorship resistance. So it must be uncensorable, and very related, it must be unconfiscatable. Your rights, if you own the rights, your assets, if you own the assets, should be unconfiscatable. And these three are very much coupled together, because confidentiality reduce ability to censor. Confidentiality makes it really hard to confiscate if you don't know what to confiscate. But unfortunately, they are not like you have one and you get the rest. Each of these has to be addressed separately in order to build a real anti-fragile system. And the final value is trustless. So still, while the system is individualistic, it is created for individuals to interact in an uncensorable, confidential way, without technical ability to violate existing rights. Why it's important? Because in such a system, which is confidential and uncensorable and unconfiscatable, you have no enforcement. You can't have an enforcement, because enforcement means censorship. Enforcement means something being publicly provable. Enforcement means something that can be taken from you yet confiscated. So you can't have enforcement in a confidential, uncensorable, and unconfiscatable system. That's why you have to embed economical trustless mechanism that technically makes impossible to violate existing rights defined within the system. So these are the values. And maybe, because again, I said that it's not usual presentation, it's pretty much about the values, not technology. I propose more open discussion format. So I would be glad to hear if somebody has comments or opinions about this topic. Okay, then I probably will continue. The next part will be less philosophical and more concrete. I'd like to start with the concept of identity, and the end result of discussing the identity, I will gradually bring us to the smart contract schema or template, which we called RGB 22 standard, which will cover the actual which will be a template for those who will be doing an identity basing on RGB. Of course, there will be different ways of doing identities, and somebody may create their own schema, not follow all these standards, but our goal is to do some sort of best practices at the state of art which we can do. Probably they wouldn't be accepted by the market, but at least we can propose as a creators of RGB something that we think explores the technical abilities of RGB and at the same time matches these values. And we call this standard RGB 22. You will be able to find the actual schema description on the web, on the GitHub repository, where all the standards on PBP standards are kept. You're welcome to look on it. It is LNPBP 22, so that's why it's RGB 22. But it's quite technical description, so I will be explaining the ideas and the design of this standard. Let's start from the scratch, not from what is known today about the identity, because everything that is known today and done today about the identity doesn't match this value. So we should probably start from the scratch, and let me try to propose how we can define concept of identity. So I do believe that identity is something that is, first of all, unique, because if it is not unique, it can't be used to identify something. And it can be globally unique, or it can be unique under some well-defined scope, but it has to be unique in order to serve as an identity. The second property of the identity, it is that it has to be publicly known, because until you reveal your identity, it is not an identity. If you're the only person who knows your identity, you can't use this identity as an identity. So probably publicly not the perfect term, but at least it should be known to multiple parties, at least participating in the interaction across that identity. And the third thing is that identity must not be transferable, because if you can transfer identity, the identity do not identify the original subject anymore. So these are three properties that identity should be followed. And in regard of these properties, we can clearly see two roles related to the identity. The first role is the identity holder. So actually, it is the subject or an object which was assigned an identity. And there is also an identity owner. It was the subject, always, not an object, who has created identity and who has the right to revoke it. I will explain this in more details. For instance, I would like to identify one of my devices. So I give this device some identity. For instance, a set of numbers and letters, a hexadecimal string. And the device in this case is the identity holder, because I'm using this identifier to identify this device. And I am the identity owner, because I am the person who created this identity and who has the right to cancel it or revoke this identity, saying that you can't use this identity to identify this device anymore. So these are two roles. And of course, if you are talking about human identity, these two roles should be the same. It should be the same person. So for my personal identity, I should be the identity owner, and I am the identity holder. So if we apply these identity properties to a subject, not to an object, these two roles must be the same, because otherwise we have slavery, like somebody do not own his identity. It should be allowed. So by putting this all together, we can say that identity is a globally unique, publicly known, untransferable property assigned by some subject, identity owner, to itself or another object or subject, identity holder. Thus, identities must be revocable or replaceable by the owner, and owner must have a way of proving identity ownership without executing revocation procedure. So that's basically the core of the identity. And again, if somebody has to add something or do not agree with this way of putting things, you're welcome to to say and to discuss this topic.
Yeah, go ahead.
Yeah, hello, Maxim. I think this is actually very great. With the like just the core first principles, right? But on the properties, I have one issue around the word publicly known. Maybe verifiable, or maybe publicly verifiable might be a better way, because like some people wouldn't want their identity to be in public. Like a very good example is the social securities, right? So your social security, you can share it, like you don't share with people, but it's verifiable using certain like platforms.
Probably this way, right?
Yeah.
Yeah, I do agree, because I don't like the public, because it shouldn't be known globally. It may be known for a very restricted set of people or participants. And yes, I do agree that it's not should be just known, it should be also verifiable by them, independently verifiable. So yes, I agree with this.
So basically the core concept of being public, which we just changed, was to have the ability for other people that you, for example, interact with or know or need to interact with, to learn that this identity is yours and these are the properties of this identity and blah, blah, blah. So it's not posing as exposure in public, but it's giving them, yeah, I'm just trying to find the correct word.
You may expose it to public if you'd like to, but it's not core property of identity that it must be exposed to the whole global public.
Yeah. That's like the RGB concept overall. Yeah, okay, I think I got it. I don't have, I think this wording is good. I think it reflects the idea nicely. Maybe not 100% sure, but yeah, it's good for now. Thank you.
Okay. Shall I move forward or other comments? This will be probably one of the most complex slides of my talk, so I will go really slowly through it. So let's design an identity with the properties we just defined. Again, we are not even know about RGB anything at all, or we just coming from the scratch. So starting with the theorems. The first theorem is to be decentralizably assigned, assigned in decentralized way, meaning without a centralized censor. In this sense, identities must be made of entropy, meaning that if you have no central party that has the ultimate right to assign an identity, and you need a set of unique identities, there is no other way of creating identities than of entropy. Because the only way that you can generate identity to yourself, which will be still globally unique. And there is a consequence of this theorem is that decentralized identities are meaningful for humans. Meaningless. Sorry, it's my bad English. So because they are made of entropy, you can't make any meaning out of it. And that's the problem with the decentralized identities, which we'll be able to solve when we will be talking about decentralized naming, but it's a separate topic. Right now, we are not discussing that part. The second theorem, to have an ownership probability, basically what we just discussed as a verifiability and ability to verify by external parties. So to have an ownership probability under trustless conditions, identities must commit to a decentralized ledger. So basically, you need to timestamp the identity. And when you timestamped it, you can show the timestamp is as a proof that this identity was indeed created by you. The next theorem, to have a decentralized revocation procedure, we need a more complex procedure, which is a single-use seal mechanism. The single-use seal mechanism is a timestamping evolved. So basically, with a timestamp, you can create the entity, but you are not able to prove to have any history of this entity. It was just created and that's all. Single-use util, sorry, it's a way of time-stamping entity in a way that you can define the future history of it and commit to this future history in a unique way. Meaning that, for instance, you say that this will be the UTXO that is associated to my identity. And at the moment when this UTXO is spent, it means that the identity is not valid anymore. And this is publicly verifiable. And by this, you can do a decentralized revocation procedure. If something is not clear, I ask you to ask the questions, because otherwise it will be hard to remember and address all this complexity. The next theorem: to be untransferable, a client-side validation is required. Why? Because without client-side validation, you basically can pass the identity and there is no way to verify that this identity hasn't been transferred. With the client-side validation, you can see that there is, in the history, there are only revocation of the identity, and it wasn't passed like a non-fungible token, because non-fungible token can be transferred. Identity must not be transferred. So the client-side validation actually loves that story. And this leads us to the conclusion that, in fact, these properties, like single util, client-side validation, and storage of entropy related to the identity, we already have them in RGB. And of course, we can design some custom system to do the identities. But if we will take a combination of Bitcoin and RGB, we will have an infrastructure that can be reutilized in order to create identity with the properties that we just discussed. And outside of RGB, if we will try to take any other system, unfortunately, we have no other choice, because there is no single util, no any other single util system, and there are no client-side validation system yet being created outside of RGB. So without these properties, you wouldn't get the properties you are required from identity. That's why all the identity systems that are designed today by Microsoft or whoever else, whatever self-sovereign they call them are, or decentralized identities they call them are, they still do not match those properties. And still, that's why we see that RGB is required here. So that's some sort of, I wouldn't say it's mathematical, but at least logical theorems and proof why RGB can be useful for constructing identities according to the cypherpunk values. Well, maybe not cypherpunk, but the values that we believe into. And this RGB22 standard, which I said about, is actually exactly the attempt, our attempt to design such a system under RGB. Maybe it's not, it wouldn't be the final way. Maybe somebody will find a better way of doing the identity with RGB, but at least it's the best that we're able to come up with. For us, it's also a test case that RGB is capable of doing much more than tokens. So how it works with RGB identity? How it works with RGB? Identity is asymmetric key pair, which is used as an identity. So it's, if you create a private key and public key out of private key, it's globally unique entropy by definition. And that's why you can use them as an identity. No RGB here yet. So it's normal. You just generate a key pair and that's your identity. And then you use this information to construct RGB genesis. Of course, you don't put a private key, because the private key is your ownership of the identity. You create a signatures with that, but you can publicly use public key, and you include that public key into RGB genesis. Genesis may also contain arbitrary supplementary data, and here we are actually absolutely blind to the actual format. So we don't want to go into this field saying that we should define a new standard for keeping identity properties, like that's name of the identity, email, whatever. because it's not our topic and our goal. So instead of that, we say that we use external data storage. We have this concept in RGB already, like for media content in NFTs and different forms of proofs, proof of burns in fungible tokens. And we reutilize the same concept for identity. And there, in the data container, we will store the actual information about the identity. And we will be able to specify the format of this data using the media type system. Well, you probably heard about that as a MIME extensions. So basically it's MIME types, which is standard, world standard. And you can use any of existing decentralized identity or self-sovereign identity formats that you like to use to encode and store those data. Next, so basically we are not inventing anything here. And there is a need to enumerate supported standards, but basically this enumeration will come from the media type standard by, as far as I know, IETF. So it's a RFC standard, Internet RFC thing. Additionally to this genesis, when we create genesis, we identify two owned rights and two procedures, which we call revoke and replace. This actually will be used for revocation of specific identity or replacement of the identity with the new version. Like, for instance, your private key was stolen by hackers and you need to revoke that identity and provide another identity as a replacement to that identity. So regarding the confidentiality, how we can add confidentiality to the identity. Our strong belief that the true identity system must be used not to serve a single identity per person or per subject. The whole idea of confidentiality in identity and in this conflict between being confidential and being publicly exposed in order to be verifiable can be solved by a very simple trick. You must have multiple identities. You must have multiple identities which will be fixed to specific contexts. So each time you interact under specific context, each time you, for instance, log into some website or buy some goods from some merchant, you must have a separate identity dedicated to this situation. And even if the identity data will leak, they will damage just this single area. And to simplify the management of multiple identities, we propose to use the same procedure like it is used today to create hierarchical wallets, the deterministic key derivation. So basically with Genesis under RGB22 contract, you will create a single root identity which you will never share, and you will create a tree of identities out of that identities which you will be using in fact. And still, you will be able to maintain the rest of identities outside of the used one as a confidential data because of RGB confidentiality properties, such that nobody will know how much other identities do you own or which are those identities until you would like to expose that. And that is another trick we are doing with RGB is that I will be saying later, because one of the core things about RGB is the ability to prove different statements that the same identity did this thing and then it did those things. And when you use two different identities to do different things, you still can prove them by creating a partial disclosure of the path in the RGB state graph that connects those two identities. So while you will be operating under multiple identities, you will be able to prove statements whenever you want, whenever you need that, using those partial disclosures. The next thing that the derivation of the new identities have additional to revocation and replacement procedure, another procedure that we called extension. So you can basically extend your identities. Probably extension is not proper term, like multiplication or derivation. You can derive additional identities to to the used identity. So that's all about the identity. And as we just discussed, identity are not meaningless, sorry. So that's why we need something more than just identity, which I will be talking in a moment. And then I will be talking about reputation, how basically from that kind of identity, you can build a very complex and advanced and confidential and trustless reputation systems. But probably some discussion before we move to the next part.
Guys, go ahead. Someone raised his hand.
Yes, hi. Thanks for the for scheduling this thing. I had a question about the identity. Since one can revoke and replace an identity, is it possible to prevent a revocation or no? Assuming I need to assign an identity to a software or a device, and I don't want that identity to be revoked in case my private key is leaked or something. I want it to be to remain unrevoked. Is it something that we could do, or?
Well, we have a core assumption here that you have to keep your private keys secure, because if you lose them, you lose your Bitcoins, and if you lose them, you again will lose your identity. So the way it works is basically when you lose the private keys, the only thing that you can do is to revoke identity and replace it with other identity as soon as it happens. Because you just replace it with other identity, and now you're again in the ownership of the identity. And that's the whole idea. Because you can't, the private key you use to sign Bitcoin transaction is the core security assumption.
Right, so basically if I want an identity not to be revoked, they can just throw away the private key since it's not going to be used for any signing a transaction.
Yes. Well, the identity key and Bitcoin transaction private key must be different keys.
Right.
And they have very different usage. The identity private key is used to prove your identity. Bitcoin private key, it's still a form of identity, but you can't manage it the same way you can manage this identity with RGB. So they have to be distinguished. And if you lose your private key identity, your identity private key, you're still the only person in the world that can sign transaction revoking that identity. And you have to do that to notify everybody that this identity is not valid anymore. And then you can define a new key which will hold the same identity. The other scenario is that you are losing your Bitcoin private key. And the worst case scenario is that somebody will be able to revoke identity, but they wouldn't be able to revoke to create a new identity, replacement identity, because they don't have access to your private key related to the identity. And the final scenario, so you're still protected here. You just lose your Bitcoins and that's all, but not the identity. And the final scenario is that you lost everything. And in that case, you have the only option to be first who will revoke the identity and use that private key. Otherwise, you lose your Bitcoins and you lose your identity. But again, unfortunately, we can't design a perfect system protecting from the loss of the all private information.
And an identity, what are its capabilities or restrictions? For example, can I sign a task or an action using the private key of an identity, or I can only do that with a private key of a wallet, such as a Bitcoin wallet?
Well, actually, we are trying to be agnostic of the applications of this identity. So what we are trying to solve is to create identity management system, but not enforce or even think about any ways how this identity can be used. So it will be completely up to the software implementation, and it's not related or affected by RGB as this relocation right management system and the system that allows you to link multiple identities. So you can use these identities the way you use them in PGP or GPG or any centralized system whenever you use, because you are not restricted to use Bitcoin elliptic curve keys. You can use RSA keys from PGP for that identity management. There are no restrictions in this regard.
Right. but they do have the ability to sign, let's say, a message.
Yes, as with OpenPGP or GNU PGP or GPG.
Thank you. That's all I had.
Okay, and you actually pointed in a very good thing, which we need probably to check that it is possible with the current design and modify it if it's not possible, is that if you link one of your identity keys and your Bitcoin key together, but you still have a root identity key, you still must be able to revoke that identity and replace it. So this hierarchy of identities must help you in managing the security. So you can, for instance, keep one identity key on a server, on a hot wallet, let's say it that way. And if it's lost, you still can revoke it by using a key offering hierarchy.
Makes sense. Thank you.
Yeah, you're welcome. The next thing is naming. So again, let's start from scratch with the definitions. And the name is unique, meaningful identity. So it's a sort of identity that is meaningful. And meaningful means that it can be understood by humans. So the only thing why we need name is humans. So they have to be able to understand it and use according to their human protocols, like ability to pronounce, visually check, and think about it. So that's the way humans usually work, and we have to accept that, unfortunately. So that's why we need a naming system. The properties are that names can be transferred, unlike the identity. So it's not identity in fact, but it's identity-like thing. So you can transfer name, and you can transfer ownership of the name, like ownership of the brand name. And names can't be confidential, because that's the core property, unlike the identities where you can do tricks with the confidentiality and they shouldn't be public. Here we can say that the brand only, there is no incentive of having confidential brand name. It's meaningless. And if we apply 3 principles, like if we will use a Homestead Principle, meaning who is the first of defining some name, he is the actual owner, timestamps and proof of work, names can be made individualistic, trustless, and anti-fragile in terms that they can be assigned in decentralized way. So we can't have all values matched with the names because of their core nature, but at least we can do what haven't been done to the naming system yet. Well, I wouldn't say that it haven't been done, because we had, for instance, Namecoin, which is actually a proof of work based timestamping utilizing Homestead Principle. So you can use Namecoin to create names. The only problem with the Namecoin that it has additional properties like introducing a new token not needed anywhere else, while with RGB you can do this with Bitcoin, not introducing any new currency or any new token. So also by using Ledger, names can be made uncensorable and unconfiscatable. That's why Namecoin also have disadvantages comparing to the system based on Bitcoin Ledger, because the price of 51% attack on all other proof of work algorithm than Bitcoin is lower than Bitcoin on Bitcoin, so you have a worse security. The question how you can resolve names in decentralized way, and actually this can be also achieved by using a global P2P network, maintaining decentralized distributed hash table like BitTorrent or IPFS or many other systems. And this hash table will operate on data which are basically RGB disclosures about the naming. And you can put such system, a global P2P network with rich table and using RGB on top of Lightning Network. So you can take these things which we are building in LNPBP Standards Association, generalized LNP protocol and its implementation as LNP node, and RGB, And outside of the scope Lightning Network channels, without creating channels, you can reutilize the infrastructure to construct a decentralized name resolver that will basically use RGB disclosures to resolve names into the identities. And this will be very scalable because you are not, the only time you need to create a Bitcoin transaction is when you create, when you register a name. And that's all. And you can, or do a name transfer, but you don't need to create a Bitcoin transaction or even do a Lightning payment for name resolution. But if you'd like to provide, to ask for a few Satoshis or even sub-Satoshis for name resolution, you can also simply embed that property into the name resolver service. So basically, what it gives us is a way to build DNS without any central authority in decentralized way, trustless, unconfiscatable, and uncensorable. How we do that? Well, we must timestamp to a single UTXO, and this becomes name genesis. This also is a spam prevention because this costs money. So as squatter, you wouldn't be able to register a lot of names because with each registration, you have to create a Bitcoin transaction. And that is actually, it costs something. And also this timestamping is the proof of the time when you have registered certain name. And if somebody else has registered his name before you, your name wouldn't be a valid name because who was the first, that party wins. The second thing you have to do is to publish it immediately to Lightning or Bifrost network. Because here we have some property of consensus-like thing that actually until this network, Lightning Network, is operated by majority of honest nodes, which we assume true. Otherwise, Lightning Network itself will have a lot of problems. So we are reutilizing the security properties of Lightning Network. If you publish your name to this network, the network maintains ephemeral state, and like Bitcoin network, it will reject the name which is already registered. So basically, you wouldn't be able to provide a name which replicates the name that has been already registered. And that is incentivizes you to publish the name as soon as you timestamp it. If you, for instance, have registered some name and haven't published it, but somebody else registered the same name later and published it, and a consensus defined period of time has passed, the network will still reject you. So this Homestead Principle will operate unless you are publishing the name the moment you have registered, like several seconds after the registration. Otherwise, you lose your rights and the decentralized network will reject this name. So that's actually the way how we can maintain the decentralized hash table of names without the property. We don't need proof of work or something like that to maintain this decentralized hash table. Each party interested in using name keeps track of the network announcement, like Lightning Network gossips for historical reasons, and may verify that the network actually is run by the honest players and is not controlled by a hacker. So you can verify the state of the network against your history, which is sort of user-activated protection, like user-activated soft fork in Bitcoin. Of course, it works differently, but the principle is the same. And name to identity resolution happens with a special state extension signed by the current name owner. Let me explain this sentence. So how it works: when you register in a name, you are an owner of that name. But now what you need to do is the name resolution. And the name resolution is basically the mapping from the name to identity. For instance, your identity is the Tor address of your server. And you bought a name, you registered actually, a name which is, let's say, Google, I don't know, Google. And now you need to say that Google is that public key of that Tor node. And you do that using RGB, reutilizing RGB. You create a special state extension. State extension in RGB is an analogy of state transition, but you don't need to commit to that. You don't need to create a Bitcoin transaction and commit to that data. And instead of state transition, you create state extension, saying that this name, Google, is now mapping to this Tor address, to this identity, and you sign that with your identity key. So that's why you don't need to commit it into Bitcoin blockchain, because your signature is a proof of that decision. And it's not a mistake if you will create a multiple name resolution. It's still fine, like with the DNS, you can have multiple IP addresses mapping to the same domain name, the same with identity and naming. So you don't need to preserve this property of uniqueness of the history, where you require single-use seal, but instead you are using the scalability of off-chain client-side validation that is provided by RGB, utilizing your signature. And that's actually how you create a name resolution record, like DNS record. And you provide this record in form of RGB, disclosure, state disclosure, publish that into Bifrost network. And from that, the network indexes this as a part of the DHT, distributed hash table. And now everybody asking the Lightning Network node about name resolution, they will get answer about how this name can be resolved into a server address. So that's the way how it works. And basically, what I just said is the ownership is proven by the fact that you sign this name resolution record. So that's all for decentralized naming system made of RGB, Bitcoin, Lightning Network, without introduction of any new blockchain or any new token, coin, and whatever. And before we will move to the last part, probably let's discuss this one.
I guess we can just move. Guys, if you have any questions, you can speak up or just drop them to the chat.
And the final part is reputation. So what is reputation? Well, in fact, reputation is an attribution. So reputation is a set of attribution, or we can name them provable claims. And attribution or a provable claim is a link between two identities, or a name and identity, and that's all. So you can build arbitrary complex attribution systems out of the graph linking two identities with a provable link. If you, for instance, the name resolution is a form of attribution. We already have just discussed it. And attribution can be also trustless if identities are anonymous. It can be final and uncensorable if it is timestamped. And it may be confidential if it is made with client-side validation. So again, we're coming to the RGB. Why attribution and reputation system needs RGB. And how we can build attribution with RGB22 identities. We need to have derived identities, which we just discussed, where we have some root identity and use similar algorithm to hierarchical Bitcoin wallets for deriving more of them. And this part is validated client-side with RGB data. You don't need a blockchain part for these probably derived identities. Genesis identity will be never disclosed. and must result in a tree of identities, each of which may be disclosed individually. The most important that you create those identities with the same state extensions you do the name resolution, meaning that you are not required to do a Bitcoin transaction to create those identities, which is also important. With each level, tree of identities branches down to leaves. So with each level, tree branches down to leaves. You must have a higher probability for the need of identity link. What it means that, like, the deeper you go in the identity tree, the more risky this identity in terms of losing. You mean you can risk more with losing this identity, you can revoke it later. And you also need to take into consideration that the probability that you will need to link two identities at the deeper level is higher. So the deeper the level of identities, the higher probability that you will need to link them. So for instance, if you buy if you use one identity to buy one good and the second identity to buy similar goods, they have to be close and deep to each other. Comparing to when you use one identity to log into a website and the other identity to sign important contracts with your company. So these identities has to be separated with significant space. And the tree is actually made of state extensions, meaning that you don't need to create a Bitcoin transaction. You will be able to attach external signatures, attributions, or names to each individual identity. And again, it should be done with a state extension. What it means, like in a web of trust, others sign your key. And the same, basically, you have the web of trust inside RGB. Your identity that you have created with RGB22 can be signed by others' identities, creating this web of trust, and this data will be included as a part of these signatures will be included as a part of your identity and maintained within the scope of the client-side validation data. So with such a system made of identities, naming, and reputation, we have a situation where basically it just repeats that everything that I described in the previous slides, meaning that identity is a public key from RGB22. Proof of identity ownership is a signature with a corresponding private key. Revocation or replacement is done with a special Bitcoin transactions linking to RGB22 state transitions. Claims are proven by RGB disclosures, parts of the state history. You can prove link, you can prove used name, ownership of the used name. You can link different identities, and you can prove a set of claims for building a reputation system out of the identity. And in fact, your reputation is a specially constructed RGB disclosure containing linked multiple RGB contracts from probably other schema with your identities. So that's how you can construct your identity, your reputation. For instance, you may be a node operating a Storm, a decentralized storage protocol, and you would like to prove your identity. And each time when you satisfy your client, the client signs with his identity, your identity, plus claim that I've been satisfied with the service of this identity. And you will maintain this data as a part of your RGB history, and you will disclose the necessary part of the RGB history to future clients, proving the historical identity. And if these clients will know the identities who were using your server and trust them, like it works in the web of trust, they will be able to assess your risk and assess your reputation. So that's how it works. So it's basically a web of trust on steroids, let's say like that. And this steroids is the ability to create multiple identities, confidential identities, which can be linked together only when required. The second property, you have a provable revocation procedure without centralized servers, without the need of any specific servers. And the third, you have a decentralized naming system and decentralized name resolution operating on top of Lightning Network. So it's basically Web of Trust breached with a Bitcoin and Lightning Network world using RGB and client-side validation. I will probably end the presentation here because it's already quite complex. I will just say that there are a few more slides which we will publish, and I'm just not sure that I will be able to explain them in text. They basically describe the internal data structure used for construct RGB 22 and 24 schemata. And I invite you to read them and check against the schema code if you'd like to dig into more details. And you're welcome to ask the questions regarding them if you will have more questions and will need more information on this part. As the final thing, I would like to say that this is a result of about a year of research that was made inside the LNPBP association. A lot of contribution came from Sabina, who is also present on this call, and who is a game theory expert. And this all actually appears from our previous experience. My team, basically, who are heavily involved these days with RGB, including Sabina and Olga here. We've been working on reputational systems for quite a long time, and one of the reasons we've been interested in RGB was the fact that we saw this potential of RGB being used as a Bitcoin and Lightning native system for building these components, which can be used further to build trustless things for decentralized storage and computation, which are the other protocols that we have in mind, called Storm and Prometheus, and of course we wouldn't be touching them today at all. So that's all on my side. Any discussion?
There is a comment in the chat. So thank you for the presentation, Maxim. May I ask what are your thoughts on EON, a layer 2 of Bitcoin for decentralized identity by the Decentralized Identity Foundation?
Well, my thoughts are, I just don't understand the exact problem that they are trying to solve. So 90% of the standard is devoted to the structure of data related to the identity. We are not touching that problem at all here. And if they needed a better structure or another standard for structuring identity-related data, well, they created one, and somebody who likes it can use it jointly with what we did here, or use any other standard. They're not better or worse than any other. So somebody using JSON, somebody using XML, somebody's special form of JSON, somebody named the fields that way, somebody named the fields the other way. It doesn't make any difference to me, for instance. It depends on the adoption and which will become more popular standard. The other part of ION is basically maybe it's 5%. They're saying that we are committing to a Bitcoin blockchain. And they are doing that in the worst possible way. Like we need to do something with the anchoring, which is basically no single use seal is used, meaning that you can't have a deterministic revocation, decentralized revocation. Like, why do they did that? That's the only question that I had. What's that all about? What problem it should solve? Creating another standard for structuring the data, or using Bitcoin and blockchain in an arbitrary way just to say that we are blockchain based? I just don't know. That's my thoughts about that. Other questions? I see somebody would like to speak, at least Jitsi says so. Olga?
No, I don't see any hands raised.
It says Mass would like to speak. But
it's an old notification.
Ah, okay. Other questions?
Yeah, sure, go ahead.
Yes, Yes, can you hear me?
Yeah. Yes.
Yeah.
Okay, so my question was that basically if I want to use this identity system, but I want to preserve my privacy, I would have to not reuse any identity. So it would be like single-used identity. But so this would be more if I use it in a client way, if it makes sense. But on the other side, if I want to access, let's say, a server, so I will have to use a name, and so the name will be linked to an identity. But in this way, you don't want to change your identity too often because you would have to make a new Bitcoin transaction to reallocate this name to a new identity.
Yeah. I got your question. Not exactly like that. So basically, identity is what it is. It's identity. So it's not like with Bitcoin that you need to change your identity each time. You need to change your identity each time you change the security or underlying risk scope. So for instance, if you have created an identity which you used with the Facebook, there are no need for you to create new identity each time you log into the Facebook. So this identity will be scoped to Facebook, and you will continue using the same identity each time you go there until somebody has stolen that, and you will just revoke it and replace with other one. But when you need to create a new identity is, for instance, you use this identity to log into Facebook, but it's recommended you should use a different identity to log into Twitter, and a different identity to log into GitHub. Or, okay, you can use the same, but it will be the same situation like reusing Bitcoin key. So you just increase your risk exposure. So that's why you wouldn't have the problems with managing multiple identities for Facebook, unless you would like to have multiple accounts for Facebook, not linkable to each other, until you would need to prove that link. And I will show you, I will show you the actual implementation of this thing we were playing with. Is actually the RGB Explorer site which we created, RGBX, and you see that there you can register RGB fungible tokens and the future identities and the rest here. But even today, when you list your assets, you provide a genesis, you provide your public key, which here operates as an identity, and your signature created on this genesis with the private key matching this public key. And there is no other login on this website. You are just authorizing when you do the operation, but you don't need to create login to use the website otherwise. And you see that here we are 8 assets listed under 3 different issuers, meaning that 3 issuers, there are 3 public keys which were used here, and this 3 public key has created 8 assets. So these are 3 identities, different identities which were used. So you can reuse identity, it's fine, and you actually have to reuse identity if you would like to delist asset. Because if you will be delisting asset, you will need to specify the asset and a signature created with the same public key you used to list the asset. So that's how we were able to construct a website for publishers, asset creators, without the need of any registration procedure, login procedure, or storing any client side, any client data at all. You don't have even Google Analytics here. And on the server side, the only thing that you have is basically these identities of your issuers, which are the public keys, anonymous public keys. And that's how the system, basing on that type of identity, is working. And of course, we will be bringing this identity system we were talking today into it during the further evolution of this product. Okay.
So any more questions, guys? Well, I guess we can wrap this up then.
Yes, thank you everybody for participating.
Thank you for joining us today. And if you have any questions, you can either drop them in GitHub discussions that we have, or drop them to our common Telegram RGB chat. Thank you very much for being with us today. Have a good day. Bye-bye.